Learning objectives. At the end of this topic, you will be able to learn surface area of a cube, cuboid and cylinder by formulae, understand how to calculate surface area of combined figure involving cube and cuboid. Cube, cuboid and cylinder. In this topic, we are going to learn the surface area of a cube, a cuboid and a cylinder. Vertices are the points where edges meet. The singular form of vertices is vertex. A cube has 8 vertices or corners, 12 edges, and 6 faces or sides. A cuboid has 8 vertices or corners, 12 edges, and 6 faces or sides. L is the length of the cuboid. B is the breadth of the cuboid. H is the height of the cuboid. A cylinder has a circular base of radius r and a height h. Surface area of cuboid, cube and cylinder by the formula method. We know that every cuboid can be divided into 6 rectangles. Area of each rectangle is equal to the product of its dimensions. Let area of rectangle be equal to A1 equal to B into H. Let area of rectangle be equal to A1 equal to B into H. Let area of rectangle equal to A2 equal to L into B. Let area of rectangle equal to A3 is equal to L into B. Let area of triangle equal to A4 is equal to L into H. Let area of rectangle equal to A5 is equal to B into H. Let area of rectangle equal to A6 is equal to L into H. Therefore, the total surface area of the cuboid is equal to A1 plus A2 plus A3 plus A4 plus A5 plus A6, which is equal to LB plus BH plus LH plus LB plus BH plus LH. Hence, total surface area of the cuboid is equal to 2 into LB plus BH plus LH. Every cuboid can be split as 6 equal squares. Let us take each square has side L. Therefore, the area of a square is 1 square. Hence, area of square is 6 into L square. Consider the cylindrical figure whose base radius is r and height h. Cut the top of the cylinder, cut the bottom of the cylinder, and cut the middle part of the cylinder vertically. Open it. We can get 1 circle in the top and 1 circle in the bottom and 1 rectangle in the middle. Area of the top circle is pi r squared. Area of the rectangle is 2 pi r h. And area of the bottom circle is pi r squared. Total surface area of a cylinder is equal to area of the top plus area of the middle part plus area of the bottom equal to pi r squared plus 2 pi r h plus pi r squared is equal to 2 pi r into h plus r. A box is in the form of a cuboid whose external measures are 40 centimeters into 30 centimeters into 20 centimeters. Find the total surface area. Solution. Let the length of the cuboid be equal to L is equal to 40 centimeter. The breadth of the cuboid equal to B is equal to 30 centimeter. Let the height of the cuboid equal to H is equal to 20 centimeter. Total surface area of the cuboid is equal to 2 into LB plus BH plus LH is equal to 2 into 40 into 30 plus 30 into 20 plus 40 into 20 is equal to 2 into 1200 plus 600 plus 800 is equal to 2 into 2600. Total surface area of the cuboid is equal to 5,200 centimeters square. Find the total surface area of the cube whose side is 5 centimeter. Solution. Let one side of the cube be equal to L equal to 5 centimeter. Total surface area of the cube is equal to 6 into L square is equal to 6 into 5 square is equal to 6 into 25. Total surface area of the cube is equal to 150 centimeters square. In a building, there are 10 cylindrical pillars. The radius of each pillar is 14 centimeter and the height is 2 meter. Find the total cost of painting the curved surface area of all pillars at the rate of 4 rupees per centimeter square. Use pi is equal to 22/7. Let the radius of the pillar be equal to r equal to 14 centimeter. The height of the pillar is equal to h is equal to 2 meter is equal to 2 into 100 centimeter. Therefore, the height of the pillar is equal to 200 centimeter. The total surface area of one pillar is equal to 2 pi r into h plus r square units. That is 2 into 22/7 into 14 into 200 plus 14. That is 88 into 214. Total surface area of one pillar is equal to 18,832 square centimeter. Total surface area of 10 pillars is equal to 18,832 into 10 is equal to 1,88,320 square centimeter. Cost of painting curved surface area is 4 rupees per square centimeter. Total cost for painting 1,88,320 square centimeter is equal to 1,88,320 into 4 is equal to rupees 7,53,280 rupees. The diagram shows a winner stand. The upper part is a cube with edges 0.4 meter. The length of the cuboid is 1.2 meters and its breadth is 0.4 meter respectively. What is the total surface area of the stand? Let us find the surface area of the cube first. How many faces can we see in the cube in this stand? 5 or 6? In a three-dimensional composite shape, the faces connecting the two 3D shapes are excluded in calculating the surface area. This means the area for the 5 faces have to be calculated. Therefore, the surface area of the cube in this 3D composite shape is 5 into length into breadth, which gives us 0.8 square meters. The length of the cuboid is 1.2 meters. The breadth of the cuboid is 0.4 meters. So what is the surface area of the cuboid? Yes, 2 faces of 0.4 meter into 0.4 meter plus 3 faces of 1.2 meters into 0.4 meter. How do you find the surface area? This part of the surface is covered by the cube. To get the area, we multiply 1.2 meters with 0.4 meters. And then subtract the connecting area 0.4 meter into 0.4 meter. Now let's calculate the area of this cuboid. Yes, the surface area of the cuboid is 2.08 square meters. Now we have the surface area of the cube and the cuboid of this composite shape. How can we find the total surface area? Good. We add both the surface areas. The surface area of the cube plus the surface area of the cuboid. We get 2.88 square meters. What if we find the surface area of the cuboid first, and then followed by the surface of the cube, before we add them to get the total surface area of the composite shape? Will the answers be the same? The diagram shows a three-dimensional composite shape made of polystyrene. If Azzi wanted to paint the composite shape, find the surface area that has to be painted. First, she needs to find the surface area of the cube. What is the surface area? The surface area of a three-dimensional composite shape is the total area of the surfaces exposed. So, how many exposed faces does the shape have? Yes, there are 5 exposed surfaces with all edges equal to 11 centimeters. So we multiply 5 with 11 centimeter and multiply by 11 centimeters. The surface area of the cube is 605 square centimeters. Now let us find the surface area of the cuboid. What do you notice about the faces of a cuboid? Yes, the opposite faces have the same measurement. So, they are identical. How many sets of identical faces does this cuboid have? This cuboid has 3 sets of identical faces. It has 2 faces of 23 centimeters by 9 centimeters. Plus two faces of 18 centimeters by 9 centimeters. Plus two faces of 23 centimeters by 9 centimeters. But we need to subtract the connecting face of the cube, which has 11 centimeters by 11 centimeters. So, the surface area of the cuboid is 1445 square centimeters. Now, what is the total surface area that has to be painted? Good. We add the surface area of the cube with the surface area of the cuboid. The total surface area that has to be painted is 2050 square centimeters. The composite shape shows two identical cubes placed on top of the cuboid as arranged by Team A. What is the total surface area of this composite shape? Let us find the surface area of the two identical cubes first. How many faces are there in a cube? Good. There are 6 faces in a cube. In a 3D composite shape, the faces connecting the shapes are excluded when calculating the total surface area. Therefore, we need to find only 5 faces in each cube. What is the surface area of each cube? Yes, the surface area of each cube is 4 cm into 4 cm into 5 faces, equal to 80 square centimeters. Now, how do we find the surface area of these identical cubes? Good. We multiply 80 square centimeters by 2, which equals 160 square centimeters. How about the surface area of the cuboid? There are 2 faces of 5 centimeters by 10 centimeters. Two faces of 4 centimeters by 10 centimeters, but the top face is connected to the 2 cubes. Two faces of 4 centimeters by 5 centimeters. So how do you find the surface area? Let's start with surface that is connected. Yes, 2 times 5 centimeters by 10 centimeters equals 100 square centimeters. 2 times 4 centimeters by 5 centimeters equals 40 square centimeters. And 2 times 4 centimeters by 10 centimeters, and subtract the connected surface. How do we subtract the connected surface? Yes, we find the surface area of the connected cubes. Two times by 4 centimeters by 4 centimeters equals 32 square centimeters. So, the surface area of 2 times 4 centimeters by 10 centimeters is 80 square centimeters. 80 square centimeters minus the connected surface 32 square centimeters gives 48 square centimeters. Now total up and we get the surface area of the cuboid. Therefore, the surface area of the cuboid is 188 square centimeters. So what is the total surface area of this composite shape? The total surface area of the two identical cubes plus the surface area of the cuboid is 348 square centimeter. Team B has built a three-dimensional composite shape using two identical cubes and a cuboid. What is the total surface area of this composite shape? To find the total surface area of the composite shape, Team B decided to unfold the shape and draw the net on a grid paper with squares of 1 centimeter by 1 centimeter. Let us begin by finding the surface area of the cuboid first. These parts are 5 centimeters by 10 centimeters, which is 2 times 50 square centimeters, equal to 100 square centimeters. These parts are 4 centimeters by 10 centimeters, which is 2 times 40 square centimeters equals 80 square centimeters. These parts are 4 centimeters by 5 centimeters, which is 2 times 20 square centimeters equals 40 square centimeters. Adding these give the total surface area of the cuboid, which equals 220 square centimeters. But what about this connected surface? What is the area of this connected surface? Look at the grid. The connected surface is a cube of 4 centimeters by 4 centimeters, which equals 16 square centimeters. Therefore, minus 16 square centimeter from the total surface area of the cuboid. So, the total surface of the cuboid is 204 square centimeters. From the grid shown, what is the total surface area of the two identical cubes? Count the surface areas that are not connected. There are 9 faces that are not connected. Therefore, 9 times 4 centimeters by 4 centimeters equals 144 square centimeters. So, what is the total surface area of this composite shape? The total surface area of this composite shape is 348 square centimeters. What can you say about these two composite shapes having the same area? Look at this diagram. The total surface area of the shaded region is 96 square centimeters. The shaded surface area of the cuboid P is 24 square centimeters. What will be the shaded surface area of the cuboid Q? What do we need to do first? Yes, we need to know the area of Q and R first. How do we find that? We can subtract the shaded surface area of the cuboid P from the total surface area of the shaded regions. Subtracting 24 square centimeters from 96 square centimeters, we get 72 square centimeters. Now, how do we find the surface area of Q? Look at the sides of the shaded regions of the cuboid. Are they of the same dimensions? Yes. Therefore, the surface area of the cuboid Q and R are equivalent. So divide 72 square centimeters by 2, we get 36 square centimeters. So the surface area of cuboid Q is 36 square centimeters. The diagram shows a combination of two cuboids T and Q and a cube R. Given that the shaded surface area of cuboid Q is half of the surface area of cuboid T, the shaded surface area of the cube R is 1/3 of the shaded surface area of the cuboid Q. What is the length of A? How do we find the length of A? What do we need to do first? Let us start by finding the shaded surface area of cuboid T. Cuboid T has a shaded face of dimensions 3 centimeters and 8 centimeters, which means the area of the shaded region is 3 centimeters into 8 centimeters, which gives us 24 square centimeters. We know that the shaded surface area of the cuboid Q is half the surface area of the cuboid T. So, halving 24 square centimeters gives us 12 square centimeters. Therefore, the shaded surface area of cuboid Q is 12 square centimeters. Now, what about the shaded region of the cube R? The shaded surface area of the cube R is 1/3 of the shaded surface area of the cuboid Q. So, what is 1/3 of 12 square centimeters? Very good. 1/3 of 12 square centimeters is 4 square centimeters. This means that the shaded surface area of the cube R is 4 square centimeters. Now how do we find the value of A? We know that the area of the shaded region of cube R is 4 square centimeters. The face of a cube has 4 equal sides, so its length is equal to its breadth. Can you think of a number when multiplied by itself gives you 4? Yes, it's 2. Therefore, the length of A is 2 centimeters. Let's visualize how the multipurpose box will look like. Which 2 faces do you think should Rahul join? The opposite faces of the cuboid are of the same size. In fact, Rahul can join any face of the cube with any face of the cuboid. But Rahul wants the multipurpose box to have a common height, so he joins the base of the cube and the top face of the cuboid. This is how the new shape looks. What shape is it? It's a 3-dimensional composite shape made of a cube and a cuboid. It is rectangular in shape. What is the height of this 3-dimensional composite shape? The height is 12 centimeters. How do you find the amount of wrapping paper needed to cover the faces of this rectangular box? This means we need to calculate the surface area of this 3-dimensional composite shape. What is the length of the shape? Add the length of the cube and the cuboid. Add the length of the cube and the cuboid. 12 centimeter plus 24 centimeters equals 36 centimeters. The length is 36 centimeters. What is the area of this rectangular face? Multiply the length 36 centimeters by the breadth, which is 12 centimeters. That gives 432 square centimeters. How many rectangular faces does the shape have? It has 4 rectangular faces. So multiply 432 square centimeters by 4. That equals 1728 square centimeters. What about these 2 square faces? The area of each square face is 12 centimeter into 12 centimeter. That gives 144 square centimeter. Now multiply 144 square centimeters by 2. The area of these 2 faces is 288 square centimeters. What is the surface area of this 3D composite shape? The surface area of this 3D composite shape equals the total of the areas of 4 rectangular faces plus the area of the 2 square faces. So add 1728 square centimeters to 288 square centimeters. The surface area of this composite shape is 2016 square centimeters. Therefore, the amount of wrapping paper needed to cover the faces of the multipurpose box is 2016 square centimeters. Now, how would you open this box? Yes, cut along these three edges to make the lid. This is the end product. Now Rahul can be proud of his multi-purpose box. Raj has 3 boxes made of mandala cards. Two of them are cubes of the same size and a cuboid. Raj wants to combine these 3 boxes in this way. After combining them, Raj wants to paint the cubes in pink and the cuboid in purple. What is the surface area that will be painted pink? What is the surface area that will be painted purple? How would you solve this problem? Let's draw a diagram. We can use this grid paper to draw the net of the cube and the cuboid to find the surface areas. Each square of the grid paper measures 1 centimeter by 1 centimeter. First, we need to open the cube out flat. Place it on the grid paper and trace along its edges. How long is each edge of the cube? Each edge is 3 centimeters long. What is the area of each face? The area of each face is 3 centimeter into 3 centimeter. That equals 9 square centimeters. What is the surface area of the cube? A cube has 6 faces. So multiply 9 square centimeters by 6. The surface area of the cube is 64 square centimeters. Now open the cuboid flat to draw its net. Place it on the grid paper and trace along its edges. From the net, what can you say about the cuboid? This cuboid measures 4 centimeters by 3 centimeters by 6 centimeters. What else did you notice about the net? This cuboid has 3 pairs of identical faces. The yellow faces measure 4 centimeter by 3 centimeter. The area of the yellow faces is 4 centimeter into 3 centimeter into 2. This equals 24 centimeters. The green face measures 3 cm by 6 cm. The area of the green face is 3 cm into 6 cm into 2, and this equals 36 square centimeters. And the blue face measures 4 cm by 6 cm. The area of the blue face is 4 cm into 6 cm into 2. This equals 48 square centimeters. What is the surface area of the cuboid? Total up these three areas. The surface area of the cuboid is 108 square centimeters. Now we can fold back the open boxes into cubes and cuboid and join them like this. What is the surface area that will be painted pink? Will this surface area be the same as shown in the net? The total surface area of these two cubes is 108 square centimeters. The area of each face is 9 square centimeters. But these two square faces are joined to the cuboid. They are hidden inside. Only 5 faces of each cube will be painted pink. We need to minus 18 square centimeters from 108 square centimeters. The surface area that will be painted pink is 90 square centimeters. What is the surface area that will be painted purple? The surface area of the cuboid as shown by the net is 108 square centimeters. What about these two parts of the faces that are joined to the cube? These hidden parts of the faces have the same area of 18 square centimeters. So subtract 18 square centimeters from 100 square centimeters. That equals 90 square centimeters. The surface area that will be painted purple is also 90 square centimeters. What is the total surface area that will be painted? The total surface area that will be painted is 180 square centimeters. Now figure out different ways of drawing the nets of the same cube and cuboid. How many ways can you do it? Summary. Let's summarize the topic. Surface area of a solid is the sum of the areas of its faces. Surface area of a cuboid is equal to 2 into LB plus BH plus HL. Surface area of a cube is equal to 6 L square. Surface area of a cylinder is equal to 2 pi r into r plus h. You have learned to find the surface area of 3D composite shape consisting of a cube and cuboid. The surface area of a 3D composite shape is the total area of the surfaces exposed. The faces connecting the two 3D shapes are excluded when calculating the surface area. Jasmine constructs a composite 3D shape using two wooden blocks, P and Q. P is a cube and Q is a cuboid. She wants to cover all the vertical faces with red cardboard and all the horizontal faces with blue cardboard. Find the difference in the area of the cardboards used.